Earlier today, my sister asked if I ate the last cookie. She said the box is empty, there's nothing in it. That got me thinking, can anything truly be empty? Well, no, because of something called quantum fluctuations. But what are quantum fluctuations, and why do they matter? Before we can understand quantum fluctuations, we need to understand the Heisenberg uncertainty principle. Along with other things, the Heisenberg uncertainty principle states that there's a trade-off between how accurately you can know the energy in an area and how accurately you can know the time in an area. In other words, over shorter and shorter time spans, we know the energy in the area less and less accurately. When there's less accuracy in energy, the energy in an area can likely be in a wide range of levels. Since it doesn't have to be at one level, the energy will constantly and randomly change. Imagine a teeny area, where each billionth of a second it flips a coin to determine its energy. In one flip, the energy can either be 100% heads or 100% tails, which is a pretty wide range. But over more and more coin flips, it starts to average out at 50-50 odds. Just like how only over longer periods of time do we know the energy more accurately. Another thing we need to know is quantum fields. Now, particles behave really weirdly at small levels, so we imagine the universe and space as fields. Instead of an electron just being a point in space, we imagine it as a spike in a field. The same goes for any other particle. That means that you and the entire world is just groups of trillions and trillions of spikes on these fields. Now, since space is made up of fields, and we can't know the exact amount of energy there is over a shorter period of time, these fields will actually fluctuate with different levels of energy. Those fluctuations make temporary spikes and holes in the fields. Since we know that spikes in the fields are really just particles, those spikes and fluctuations create particles that appear out of nowhere. The same goes for the hole, which creates what we call an antiparticle. As soon as they appear, they collide into each other, canceling each other out. These fluctuations are constantly happening all around you, and they happen regardless of the circumstances, because that's just the way space itself behaves. To summarize, when adding the Heisenberg uncertainty principle to space being made up of fields, we get quantum fluctuations. So really, the cookie box isn't empty, and that's because quantum fluctuations are constantly appearing in and all around it. So why does this matter? Well, we wouldn't exist without quantum fluctuations. Right after the Big Bang, when the universe was just a small, rapidly expanding ball, quantum fluctuations made some areas more dense than others, and stretched out to massive distances, the more dense areas were pulled together by gravity, making galaxies. Without quantum fluctuations, the universe would just be a big, evenly spread out ball of gas, with no stars or planets. So whether you're trying to convince your sister that the cookie box isn't empty, or you're just admiring the universe, you can thank quantum fluctuations.